Well, so we'll go for the problems on Coulomb's law. The first question is, calculate the Coulomb's force between two alpha particles. Coulomb's force between two alpha particles separated by a distance of 3.2 into 10 raised to minus 15 meter in air. So the given charged particles are alpha particles. There are two alpha particles given, and they are separated by a distance of 3.2 into 10 raised to minus 15 meter in air. They are separated in air. There is no any medium. It is an air medium. Well, so let us say that two charges Q1 and Q2, both are alpha particles only. The first charge Q1 is also alpha particle only. The second charge Q2 is also alpha particle only. These two alpha particles are separated by a distance of 3.2 into 10 raised to minus 15 meter in air. So this much is the distance between the two alpha particles. This is the distance. Okay. So we got to know that two alpha particles are separated by this much distance, and we have to find out what is the Coulomb's force between these two alpha particles. See, basically first we know that alpha particle means it is helium nucleus. And helium nucleus means we know that we represent it in this way. Helium nucleus means we represent it as 2He4, where 2 is atomic number which represents the number of protons, and 4 is the mass number which represents the number of nucleons. Nucleons means number of protons and number of neutrons. We already got to know that there are two number of protons present in that, and neutrons, however, they will not be having any charge. So the charge of an alpha particle means the charge on the helium nucleus. So what will be the charge on the helium nucleus? It will be plus 2e. This much will be the charge. I am taking it as plus 2e because there are two protons present in it. That's why I am taking the charge of an alpha particle as plus 2e. Okay. Even this is also alpha particle, so I can write it as plus 2e. So these are the two charges separated by a distance of 3.2 into 10 raised to minus 15 meter. We have to calculate the force between these two. Yeah, we have to calculate the Coulomb's force between these two charged particles. Well, see, to calculate the Coulomb's force, we have to use the Coulomb's law equation, that is F is equal to 1 by 4 pi epsilon naught Q1 into Q2 divided by R square. As well, we know that 1 by 4 pi epsilon meter means it is 9 into 10 raised to 9. Q1 and Q2. Q1 and Q2 means 2e into 2e divided by R square. R square means it is, okay, let us take it as R square only, R square. So this will be 9 into 10 raised to 9. So this will be 4e square divided by R square. Okay, then this can be written as 9 into 10 raised to 9, 4 into e. E means charge of a proton. Charge of a proton means it will be 1.6 into 10 to the power minus 19 Coulomb whole square. Okay, divided by square of distance between them. Distance between them is 3.2 into 10 to the power minus 15 whole square. Well, so we have to simplify this now. See, simplifying this, I mean, we have to first square this 1.6 into 10 to the power minus 19 Coulomb whole square, and then 3.2 into 10 to the power minus 15 meter. This we have to square. Okay, squaring and multiplying all the things in the numerator and keeping squaring and keeping the denominator as it is, we get this much. So 10 to the power minus 29, 10 to the power minus 30, this will get cancelled. And here the 10 to the power plus 1 will be remaining. If we take the here, it will get 10 to the power minus 1. If we take to the numerator, it will be 10 to the power plus 1. So 92.16 divided by 10.24 will be 9 into here. The remaining thing is 10 to the power plus 1. So it will be 90 Newton. Hence, the force between the two alpha particles which are placed at a distance of 3.2 into 10 to the power minus 15 will be 90 Newton. So this is the final answer. Okay, we'll go for the next question then. Next question is, how far apart two electrons should be placed so that the force between the two electrons will be equal to the weight of an electron? So this is the question. How far apart two electrons has to be placed? See, two electrons should be placed how far so that the force between them will be equal to the weight of an electron. So we know the charge of an electron will be 1.6 into 10 to the power minus 19 Coulomb. This much will be the charge of an electron. And in the question itself, they have mentioned that the force between the two electrons which are placed at certain separation between them will be equal to weight of the electron. Weight of the electron means W. So I can write it as M into G. M into G, M means it is mass of an electron. Mass of an electron means 9.1 into 10 to the power minus 31 into G. G means we know that it will be 9.8. So G means acceleration due to gravity, that we already know, 9.8 meter per second square. Okay, 89.18 into 10 to the power minus 31 Newton. So this much is the force between the two electrons. But we don't know what is the distance between the two electrons which are kept at a certain distance so that they are experiencing this much amount of force. We have to calculate that distance between the two electrons. That is R we have to calculate. Okay. So we'll write the expression for Coulomb's law now. That is F is equal to 1 by 4 pi epsilon naught 1 by 4 pi epsilon naught Q1 into Q2 divided by R square. Okay. So we know the value of F, we know the value of 1 by 4 pi epsilon naught, we know the value of Q1 and Q2, we have to calculate the value of R. Okay, F is 89.18 into 10 to the power minus 31 that we have already calculated, and value of 1 by 4 pi epsilon naught is 9 into 10 to the power 9. Q1 into Q2 means E into E, it will be E square. Electron into electron, it will be E square divided by R square. We don't know the value of R square. Okay, so this can be written as 89.18 into 10 to the power minus 31 equal to 9 into 10 to the power 9 E. E means 1.6 into 10 to the power minus 19 whole square divided by R square. I want to calculate R, that's why I will equate it for R square now. R square will be equal to 9 into 10 to the power 9 into 1.6 into 10 to the power minus 19 whole square divided by 89.18 into 10 to the power minus 13. 10 to the power minus 31. Okay. So simplifying this, we will get R. Well, so R square is equal to, we got this much, squaring 1.6 into 10 to the power minus 19 whole square and multiplying it with 9 into 10 raised to 9, we get this much. We have to simplify this. Simplifying this, we will get R square is equal to 0.2583 into 10 to the power plus 2 minus 29 minus 30. And removing this 10 to the power plus 2, we will get it as 25.83. R square is equal to this much. Taking square roots on both the sides, we get R is equal to 5.08 something. So this much will be the separation between the two electrons. So if we keep the two electrons at this much separation, then the force between them will be 89.18 into 10 to the power minus 31. That is equal to the weight of an electron. We'll go for the next question then. See, two pith balls, each weighing 10 raised to minus 3 kg, are suspended from same point by means of silk thread 0.5 meter long. On charging the balls equally, they are found to repel each other to a distance of 0.2 meter. Calculate charge on each ball. Well, see, here two pith balls are given. I am calling these two pith balls as A and B. Both the pith balls are weighing 10 raised to minus 3 kg. So this is the mass of each pith ball. Both are having the same mass. They are suspended from the same point, from the point O, which is a rigid support, and they are suspended with the help of a silk thread, which is insulating thread, whose length is 0.5 meter. When equal charge is given for both the balls, if both the balls are given equal charges, then they are said to be having like charges. If they are having like charges, then there will be a force of repulsion between them. That's why if the two balls are initially together, then they will get separated due to the repulsion. Why repulsion? Because same charge is given for both the balls. Well, so due to repulsion, both the balls are separated now. How much they are separated? They are separated 0.2 meters. So this is the separation between the two balls. What we have to calculate? We have to calculate what is the charge on each ball. Charge on each ball is same. Q1 is equal to Q2 is equal to question mark. Okay, or let us say Q1 is equal to Q2 is equal to Q, and we have to calculate this Q now. We have to calculate the charge on each. Okay, see, this is the diagram, and here both the balls are at equilibrium now. Equilibrium means they are static. Okay, the distance between them is neither increasing nor decreasing. They are exactly at 0.2 meters separation. So, what are the common forces acting on this pith ball A? The common forces which are acting on this pith ball A is, we know the common force is weight, the first common force. It will always be acting downwards, that is W. And one more common force will be acting along the string, which is called tension. So that tension will be acting in this direction. And apart from these two, these are the two common forces. Okay, apart from these two, there is a repulsive force acting between these two. So in which direction that repulsive force will be acting? The repulsive force, the Coulomb's force or electrostatic force, electric force. These forces will be acting along the straight line joining the two charged bodies. That is central force. That's why it will be acting along the straight line joining the two bodies. So the repulsive force on this ball will be acting in this direction, and the repulsive force on this ball will be acting in this direction. That's why they have got separated. Okay, due to the repulsive force. So this is the repulsive force or electric force. We name it as F. Okay, so totally we are having 3 vectors here. One is F, W and T. Fine, we have to calculate Q. There is a triangle formed here, OAC. There is a triangle, right angle triangle, and here is the angle theta. So applying Pythagoras theorem for this, I can write it in this way: OA square is equal to OC square plus CA square. Fine. We know the value of OA now, that is 0.5 meter, and value of CA will be 0.1 meter on this side and 0.1 meter on this side. This 0.2 will be divided into 2 equal halves. So we got to know 2 sides now, CA as well as OA. We can calculate OC. Right? So by using Pythagoras theorem, we can calculate OC. Well, we want to calculate OC now. So OC square will be equal to OA square minus CA square. Okay, OA square is 0.5 whole square and CA square is 0.1 whole square. So 0.5 square means it will be 0.25. 0.1 square means it will be 0.01. So subtracting this, we will get OC square is equal to 0.24. OC will be equal to 0.489 meters. So this much is the value of OC. We got to know, or we calculated the value of OC now. So next, weight of the pith ball. Weight of the pith ball means weight means it will be equal to M into G. So M means we have to calculate, we have to take the mass of the pith ball. Mass of each pith ball is 10 raised to minus 3 kg, and acceleration due to gravity. Let us take that acceleration due to gravity as 10. Instead of G is equal to 9.8, it is given in the equation. Instead of G is equal to 9.8, we'll take it as 10 meter per second square. Okay, so this will be 10 raised to minus 2 kg. This much is the weight. Okay, we have taken it as 10 because value of G we have taken it as 10 because in the question it is given. Okay, W is equal to 10 to the power minus 2 kg. This much is the weight of each pith ball. See, on each pith ball there are 3 forces acting. One is electric force, F, repulsive force. Another one is weight, and one more is tension. I will draw that vector diagram here. So this is the electric force acting horizontally, and this is the weight acting downwards, vertically downwards, and this is the tension acting diagonally. Okay, so these are the forces acting. Well, so this is the line of separation, and this is the angle theta. See, now we have to resolve a vector among these 3, T, F, and W. That's why we can resolve this T now. We have to resolve T. So if we resolve T, we'll get 2 components. One is T cos theta and another one is T sin theta. So these are the 2 components. See, initially only we have told that each ball will be in equilibrium. Equilibrium means net force on that is 0. There is no force acting on it. Okay, that's why as we are saying that each ball is in equilibrium, here we can equate F and T cos theta. They both have to be equal and opposite, then only they will get cancelled and it will remain in equilibrium. W and T sin theta has to be equal and opposite. If these both are equal and opposite, if they get cancelled, if these both are equal and opposite, if they get cancelled, then only the ball will be in equilibrium. Then only the net force on it will be 0. That's why I am equating this. F is equal to T cos theta and W equal to T sin theta. We are equating this now. Okay. So what we can do now? We can do it like this. We can take the ratio now. Okay, if we take the ratio, we'll get F by W is equal to T cos theta divided by T sin theta. T and T will get cancelled, and F by W will be equal to cot theta. This much will be the F by W value. So we got F by W is equal to cot theta. See, cot theta means what we will get? We get cot theta means it will be equal to adjacent side divided by opposite side. So F means I can equate it as F is equal to W into cot theta, and F is equal to W means we have already calculated it is 10 raised to minus 2. Cot theta means it will be adjacent side divided by opposite side. So adjacent side is 0.1 and opposite side OC we have already calculated it is 0.489. So adjacent side is 0.1 divided by 0.489, and simplifying this we will get F is equal to 0.2044 into 10 to the power minus 2 Newton. So we got to know what is the force acting in between these 2 pith balls. Okay, so this is the repulsive force acting between these 2 pith balls. Next we have to calculate charge on each pith ball. That is the thing which is asked in the question. Charge on each pith ball has to be calculated. See, charge means till now whatever the formulas we have used, in that the charge appears in a formula of Coulomb's law, that is F is equal to 1 by 4 pi epsilon naught Q1 into Q2 divided by R square. So we want to calculate that Q1 as well as Q2. Okay, that's why F means we already know that it will be given as 9 into 10 raised to 9 Q1 into Q1 into Q2 divided by R square. So in place of F I have substituted its equation. And this will be equal to 0.2044 into 10 raised to minus 2 Newton. So Q1 and Q2, these both are equal, because in the question itself it is mentioned that both the pith balls are given same charges. That's why I will take Q1 and Q2 as Q. So it will be Q into Q square. I can write it as 9 into 10 raised to 9 Q square divided by R square is equal to 0.2044 into 10 to the power minus 2 Newton. Okay, well, so R square means in place of R I can take it as 0.2 whole square. See, here only the unknown quantity is Q now. Q square is the only unknown quantity. So by simplifying this, we can calculate the value of Q now. So from this equation, we have to calculate Q now. We want to calculate the charge Q. Well, so if we equate it for Q square will be equal to this much now. 0.2044 into 10 raised to minus 2, it is 0.04 divided by 9 into 10 raised to. Calculating or simplifying this equation, we will get the value of Q. Value of Q will become 0.09531 into 10 to the power minus 6 Coulomb. This is the value of charge Q on each pith ball. Okay, we'll go for the next question then. See, two charges, 2 microcoulomb and 1 microcoulomb, are placed at a distance of 10 centimeter in air. Where should the third charge be placed in between them? Where should the third charge be placed in between them, such that the force on that third charge will be 0. Force on that third charge will be 0. So no force will be acting on that. Okay, see, let the two charges be 2 microcoulomb and 1 microcoulomb, that is Q1 and Q2. Q2 is 2 microcoulomb and Q1 is 2 microcoulomb and Q2 is 1 microcoulomb. So both are separated by a distance of 0.1 meter. This is the separation between the two charges. Okay. See, let us assume that the third charge Q3 will be placed in between these two charges Q1 and Q2, and let that third charge Q3 be placed at a distance x from Q1. At a distance x from Q1. Okay. When this third charge Q3 is placed at a distance x from Q1, at that point, we are assuming that the force on this third charge Q3 is said to be 0. Okay. If the distance of the third charge Q3 from Q1 is x, then the distance of the third charge Q3 from Q2 will be equal to 0.1 minus x. So this much will be the distance. Okay, we have to calculate the force. See, all are like forces now. Q1, Q2, Q3, all are like forces. Positive, positive, and let this also be positive. Then there will be a repulsive force. So the two forces will be acting on Q3 now. Okay, because in the neighborhood of Q3 there are two charges, Q1 and Q2. So how many number of charges will be in the neighborhood of a charge? Those many number of individual forces will be acting on it by the principle of superposition. We know that. Okay, so on Q3 there will be a force acting due to Q1, and on Q3 there will be a force acting due to Q2. Okay, the force acting on Q3 due to Q1 is given as F31, repulsive force. And the force acting on Q3 due to Q2 is given as F32. Okay, these are the two forces acting on the charge Q3. One is due to Q1, another one is due to Q2. So these two forces are acting on the Q3 and both are opposite in direction, as we are saying. And these two forces must be equal, then only the force on this charge Q3 will become 0. Okay, so it is given in the question itself, the force on the charge Q3 will be 0. That's why what I will do, since the force on Q3 is 0, I can take F13 is equal to F31 is equal to F32. So these two forces has to be equivalent. Okay, F31 means it is the force between third charge and first charge. So I will name it as 1 by 4 pi epsilon naught. I can take it as 1 by 4 pi epsilon naught Q1 into Q3 divided by the distance between them is x. distance between third charge and first charge, that is x. So I'll take it as x square. F32 means it will be equal to 1 by 4 pi epsilon naught. This is the force between third and second charge. So I can write it as Q2 into Q3 divided by the distance between them is 0.1 minus x. So I will take it as 0.1 minus x whole square. Okay, 1 by 4 pi epsilon naught, 1 by 4 pi epsilon naught will get cancelled. Q3 and Q3 will get cancelled. Okay, we are having Q1 divided by x square is equal to Q2 divided by 0.1 minus x whole square. Simplifying this, we'll get it like this. Root of Q1 divided by x is equal to root of Q2 divided by 0.1 minus x. Okay, so root of Q1 means it will be root of 2 into 10 to the power minus 6 divided by x, and root of Q2 means it will be root of 1 into 10 to the power minus 6 divided by 0.1 minus x. Okay, cross multiplying this, we'll get it as root of 2 into 10 to the power minus 6 into 0.1 minus x. So this will be root of 1 into 10 to the power minus 6 into x. Okay, so I can write it as root 2 into 10 to the power minus 3 into the bracket 0.1 minus x, and this will be root 1. Root 1 means it will be 1 into 10 to the power minus 1 into x. So root 2 means it will be 1.414 into 10 to the power minus 3 into the bracket 0.1 minus x equal to 1 into 10 to the power minus 3 into x. So only unknown quantity here is x. We have to calculate x now. Okay, simplifying this, we will get x equal to 0.0585 meters. So this is the value of x. X means what is that? It is the distance at which Q3 is placed from Q1. So if the third charge Q3 is placed at a distance 0.0585 meters from Q1, then the net force acting on this Q3 will be 0. It means these both forces will be equal, they will get cancelled, and the net force on Q3 will be 0. So at how much distance Q3 should be placed? Third charge, it should be placed at a distance of 0.0585 meters from the first charge. Okay, so that is the distance. We'll go for the next question then. Consider three charges Q1, Q2, Q3. Q1, Q2, Q3, which are all equal to Q, and they are placed at three vertices of an equilateral triangle of side L. Okay, equilateral triangle means all sides will be of same length. Okay, so the three charges Q1, Q2, Q3 are placed at three vertices of an equilateral triangle. The fourth charge capital Q will be placed at the centroid of the triangle, and what will be the total force acting on the charge capital Q which is placed at the centroid of the triangle? That we have to calculate. Okay, see, all these three charges Q1, Q2, Q3 are equal, and they are equal to Q. All are of same polarity, I mean like charges. The fourth charge Q which is placed at the centroid capital Q is also of same polarity as that of Q. It is same as Q, has same polarity as that of Q. Okay, so all are of same charges, same polarity. That's why there will be a repulsive force between each two charges acting. Okay, we have to calculate the net force on capital Q which is placed at the centroid of the triangle. So net force means the vector sum of all the individual forces acting on this charge due to its neighboring charges. See, basically we know that force on any charge, how many forces will be acting on any charge? There, how many number of electric charges are present in its neighborhood? Those many number of electric forces will be acting on that charge. So on charge capital Q, there will be a repulsive force acting due to Q1. I am calling it as repulsive force because these both are having same polarity. They are like charges. That's why the force acting on Q due to Q1 will be repulsive. Force acting on Q due to Q3 will be repulsive. Force acting on Q due to Q2 will be repulsive. All are repulsive forces only, because all are like charges. Hence, I will draw the forces now. I will show the direction of the forces acting on Q1. See, the force acting on capital Q due to Q1 will be acting in this direction. Okay, it is a repulsive force. I will call it as F1. Okay, this is the force acting on capital Q due to first charge. And next, force acting on capital Q due to second charge. This will be acting in this direction, and I will call it as F2. Okay, this is the force acting due to second charge on the capital Q. Next, force acting on Q due to third charge, that is F3. It will be acting in this direction, we call it as F3. See, there are total three forces acting on capital Q, because In the neighborhood of capital Q, there are 3 charges. So how many charges will be in the neighborhood of a charge? Those many number of individual forces will be acting on it. So on Q, there is a force due to Q1, due to Q2, as well as due to Q3. Since all are like charges, they are repulsive forces only. So the force between Q1 and Q is repulsive, Q3 and Q is repulsive, Q2 and Q is repulsive. That's why I've shown the directions of forces in this way. See, the forces has to be shown along the line which is joining both the charges, because this force is central force. It will be acting along the straight line which is joining the centers of the charges. Okay, that's why I am showing the forces along the straight lines which are joining the 2 charges only. We cannot show it anywhere in any other random directions. We have to show it along the straight line joining the 2 charges only. Okay, so we got 3 forces now: F1, F2, F3. Okay, from the diagram we got to know there are 3 forces acting on charge capital Q. Okay, I will go on writing the expressions for these forces now. Force on capital Q due to Q1. Okay, this is given as F1. F1 is equal to 1 by 4 pi epsilon naught. It will be Q1 into capital Q, or let us take it as Q only, because Q1 means it is equal to Q only. Q into Q divided by distance between them, divided by distance square of distance between them is OA square. OA square into, I will write it in vector notation. So this will be it will be AO cap AO unit vector. Okay, in the same way, force on capital Q due to Q2, force on capital Q due to Q2 is given by F2 is equal to 1 divided by 4 pi epsilon naught Q into capital Q divided by OB square, and this will be BO cap. Okay, so this is the unit vector which is acting along F2. Similarly, third force acting on capital Q is due to the charge Q3, and it is written as F3. F3 will be equal to 1 by 4 pi epsilon naught Q into capital Q divided by OC square, and this will be equal to CO cap. Okay, so these are the 3 forces which are acting on capital Q. See, all three forces, that is F1, F2 and F3 are acting in this way. This is F1, this is F2, and this one is F3. All these 3 forces are acting in such a way that angle between them is 120 degree. Okay, 120 plus 120 plus 120, it will be 360. So all 3 forces are acting at an angle of 120 degree in each of them. Okay, see, next, by principle of superposition, we know that by principle of superposition, the total force or the net force acting on a charge is equal to the vector sum of all the forces acting on it due to all the other individual charges. Okay, so there are 3 forces acting on the charge capital Q. That's why the total force acting on the charge capital Q will be equal to the vector sum of all these 3 forces according to principle of superposition. So F will be equal to F1 plus F2 plus F3. Okay, what is F? See, in F1, F2, F3, we are having these things common. 1 by 4 pi epsilon, 1 by 4 pi epsilon, 1 by 4 pi epsilon. Q into Q, Q into Q, Q into Q. Okay, so I will take these things. So the total forces, F is equal to F1 plus F2 plus F3, and we are taking the common thing now. In F1, F2, F3, we are having common 1 by 4 pi epsilon, 1 by 4 pi epsilon, 1 by 4 pi epsilon, Q into Q, Q into Q, Q into Q. See, next OA, OB, OC. These all 3, OA, OB, OC, this will be equal. I will take it as R because this is centroid. O means it is centroid. It will be at equal distance from all the vertices of the triangle. That's why I am taking OA, OB, OC as R. Okay, so this will become R square, this will become R square, and this will become R square. So it will be common. I will take it as R square. Okay, what is the remaining thing now? Remaining thing is vector sum of all these unit vectors. AO, unit vector AO, unit vector BO, and unit vector CO. These are the unit vectors now. See, AO, BO, CO, these unit vectors will be acting along F1, F2 and F3. So the directions of unit vectors are same like this, and they are acting with an angle 120 degree in between them. That's why if we rearrange this, we will get a triangle in this way. If we rearrange it, we will get a triangle in this way. So these 3 vectors will be forming a closed triangle. It will be forming a closed triangle whose resultant will be equal to 0 actually. That's why the vectors AO, BO, CO will be acting along F1, F2, F3, which after rearranging will be forming a closed triangle. That's why the resultant of these three vectors is 0. Okay, see, resultant of, since, see, we know that resultant of these vectors AO, BO and CO, this will be equal to 0. If the resultant of these three vectors is 0, then what will be the net force? 1 by 4 epsilon q1 into q dot by r square into 0. It will be equal to 0. That's why the force acting on capital Q, will be equal to 0. So no force is acting on this capital Q. From diagram itself, we'll get to know that there will be no force acting on it, because these three vectors will form a closed triangle whose resultant will be equal to 0. So the 0 force will be acting on the charge capital Q.